All right.
All right. Hello, everyone. Welcome to Codementor Office Hours. Today, we're very excited to have Chris Fidao here with us today. Chris is a PHP developer and runs servers for hackers, the newsletter about servers for programmers. Today, Chris is going to talk about how to use Nginx with your web apps. Chris?
Hey, everyone. So I guess I'll just jump right in, right?
Yep.
Sure.
All right, sounds good. So I, like you said, run servers for hackers. And actually, let me start sharing my screen now. And you can see my screen now, right?
Yep.
Great. All right. So I run servers for hackers, and basically this is just my newsletter, which is all about servers, but kind of like from a programmer point of view, which is me, basically. I'm a programmer. I've been doing PHP for like 10 years or so. And I used to have a complete lack of server knowledge or even command line knowledge. And that just, made my life hard so many times that I eventually just started learning a lot about servers. And that led me to blog a lot about it. And that's kind of led to the Servers for Hackers newsletter, as well as the ebook I'm going to make or am making. It should be out hopefully later this month. So both of these things are kind of coming together, and I'm trying to teach people as much about servers as I can, especially people who might not be as experienced, but maybe just have a little bit of experience, using their Macintosh as a server or something like that, and maybe want to get into using virtual machines or, even running production servers. So today I'm going to talk about powering your applications with Nginx. So I'm going to just try to do about half an hour of talking about Nginx, what Nginx does and how it works, differentiate it versus like Apache, and just kind of give an overview of it. And then after that, we can talk about any specifics or questions you all might have. All right, so applications with Nginx. So, of course, the first thing you might want to know is, what does Nginx do? I bet you a lot of you are familiar with Nginx. It's just a web server, essentially. It's taking over. I mean, it depends what numbers you read, but some say it has taken over Apache in terms of, percentage of people using servers on a Linux-type server environment. So what is Nginx? Nginx is a web server, obviously. It serves static files and that kind of thing. An application proxy, meaning it can communicate with your dynamic coded applications. It can be used as a load balancer, so it can distribute traffic amongst one or more kind of backend servers. And it can be used as a web cache, which is like a cache like Varnish. Nginx can do that kind of thing as well, paying attention to HTTP cache headers and deciding how and when to serve files from cache instead of pull them directly from a server. So those are the high-level things of what Nginx can do. There's a lot of other things that go along with that, like it uses gzip compression to compress files it serves, like your CSS and your JavaScript and that kind of thing. SSL termination, which just means that it can read an SSL connection and decrypt it and respond to it. It does logging. There's Nginx Plus, which is the commercial product from Nginx, and that enables extra functionality. Some stuff like load balancing gets some extra features, but kind of the main features of Nginx Plus is its ability to stream music and video and that kind of media. It has some extra monitoring features, and then there's just some more extra stuff that Nginx does that most web servers do as well. So I'm going to go over each of the main things here, these 4 things of what Nginx can do and how it can work with your application. So Nginx is a web server. It does static content very well. It's, Apache and Nginx both do these really well, but Nginx is really built for high concurrency, which means that it can handle requests. It can handle many concurrent requests at the same time. And this is really down to how it manages processes. So same functionality, different process management is what that PM stands for there. So on the left here, I have Apache, and on the right, it's kind of Nginx's event loop. And this is the main difference in how Apache and Nginx takes requests and handles them and responds to them. So what I'll do is explain this, and then I'll say how Nginx can handle more concurrent requests than Apache because of it. So Apache will typically, well, actually, let me say this. So typically in any process on any Linux server, something will spawn processes, and processes can spawn threads. So a process is just your application essentially running probably in the background, and it can just do whatever your application does. And it may spawn threads, which are kind of like mini versions of the process that take up less memory and are kind of quicker and easier to work with. So what Apache typically does by default is spawn a process for every web request and every web connection technically. And then it handles that and it responds to it, and then it kills the process, and then it does the next request and creates a new process for that. And that has a lot of overhead. When you have to create and destroy processes in high numbers, that's kind of a CPU intensive task relative to other things. And it's a heavy thing for a server to have to do. So Apache has improved on this. They have other, they call them NPMs, which is multi-processing modules. Apache can spawn processes, and these processes with these different NPMs can spawn threads. And so you have the situation where a process can handle an HTTP connection, and then each thread can handle a lot of requests, or each process and thread can handle their own HTTP connection and requests at the same time. The difference between a connection and a request is that HTTP can open a request, and within that request have can open a connection, and within that connection can handle multiple requests. So what Apache does with this NPM modules is try to have a more memory efficient way of handling many requests at the same time. But at the core of it, it has this process management where it creates processes and threads, handles connections and requests, and spends a lot of overhead managing these processes and requests. A typical server with a lot of RAM, a good amount of RAM, will have many, many, many processes. It depends how much traffic it has in the server settings and on the load it's capable of taking on. But you can have, on a 1 gigabyte server, you might have like 40 plus processes set by default, kind of like waiting for connections. Nginx, on the other hand, is single process. I'm using air quotes when I say that. Because you can have more than one process, but it's very few processes and single threaded. So there's just a process and it doesn't spawn multiple threads. And this runs in a efficient event loop. So if you ever use Node.js, it's kind of like that, where you spawn a Node.js process and it's asynchronous and non-blocking and evented, so that everything is kind of running in this run loop. And it will, accept new requests and be able to handle other processes while it's waiting for other requests to finish. So for instance, if you have to read a file or have some kind of network operation, Nginx can actually do something else, process another request while it's waiting for the other one to finish. So instead of Apache's method of handling and creating a lot of processes and threads, Nginx will instead have few processes, but still be able to handle a lot of simultaneous concurrent requests because of its asynchronous nature. It can just, while it's waiting for something that takes a while to finish, move on to the next task, and just kind of keep doing this stuff in a loop. This lets Nginx handle a lot more concurrent requests, and is, it might be why we see if Apple used Nginx today. They might have been able to handle the traffic instead of like using Apache and seeing that their live feed go down all the time. So, all right. Nginx as a web server handles static files efficiently, very efficiently. In fact, sometimes as fast as a cache like Varnish. And that's not when it's caching, not being used as a web cache, just when it's being used straight up to respond to a request for static assets like a CSS file or a JavaScript file, or anything static. Cool. So this is a really basic configuration for Nginx, and this is a configuration you see just to serve static files out of a website. It's almost as simple as what Servers for Hackers website is, because it's just a static site that's generated with Sculpin, which is a PHP static site generator. But anyway, it's just static files. So we just tell it to listen on port 80, which is just regular HTTP. We tell that this is the default site. So if Nginx gets a request, it doesn't know what website to give it to, what configuration, it goes to this one because it's the default site. We set the web root at var www, which is where our web files are. We can tell it the index is index.html, or failing that, index.htm. We set the server name. So in this example, this would be a website for example.com or www.example.com. And lastly, a location block here with the try files directive. So the location block here just has a backslash, and the location block in Nginx will work to match whatever URI you give here and any subdirectory, any sub URI. So a location of just a backslash matches every single URL or URI, however you want to call it. And in this case, it'll try files, which is trying to find a file on the server. So it tries to find the exact URI, which is, usually a file. And then failing to find a file, it tries to find that URI as a directory. And failing to find that, it'll respond with a 404. So again, this is just a really basic Nginx setup for a static website with, index HTML files and CSS and JavaScript and stuff, but no dynamic application yet. So one thing of Nginx I always do is to use H5BP's Nginx server configuration setup. If you install Nginx on Ubuntu or Debian Linux servers, you typically have like this sites enabled and sites available structure already. I'm not going to go over that here, but essentially what I do is I take the H5BP configurations and always install those in my Nginx servers. And those include really useful defaults, like good expiration headers for caching. It'll have good SSL setup, so it'll use good SSL ciphers and TLS versions over older SSL protocols and that kind of thing. So it has really good defaults for SSL, for expiration, for web fonts, for security, to hide your dot files or to stop cross-site script attacks and that kind of thing. And does all this, in fact. It has a good gzip setup. It includes more MIME types to match files being used by the server and file types. Good cache expiration. I have that in bold because we'll see that is important really later. A proper, air quotes again, SSL configuration. You can use SPDY Speedy, which is Google's protocol that is sort of HTTP on steroids. And again, cross-domain protection, web font usage, cache busting. It has H5BP has a cache busting technique that they like to use, and it has some good server configuration to help you do that. And finally, security stuff like stopping cross-site scripting attacks and protecting dot files from being served directly. So that's kind of the boring part of Nginx. It's a static website, and anytime you do use Nginx, I suggest you use H5BP's HTML5 boilerplates configuration. So let's go on to something a little more interesting and talk about using Nginx as an application proxy. So when I say a proxy, I just mean that Nginx can take a web request and proxy it, send it to something else, to your application. If you're a PHP developer, and I've always have been, you might not be used to this process simply because things like MAMP and everything use Apache, and those typically have Apache's mod PHP loaded, which essentially loads PHP inside of Apache. So what you end up with is a situation where Apache is finding PHP files that end in .php, and just parsing them with PHP, and it just treats it like a static file, except it also runs PHP code inside of it. This is really an exception to how web applications work. Like, if you use Ruby or Python or Node or Go or Java or something, or PHP with PHP FPM, as we'll see in a minute, we have a more typical setup where it gets a little more complicated, and we have some more things going on than typically we would with Apache with mod PHP. So in this picture here, we see a laptop on the top, and that's just a web client. Pretend it's a browser, like your Chrome web browser, making a web request at an application. That HTTP request goes to Nginx, and then Nginx has to pass the request off to your application somehow. So Nginx doesn't talk directly to your application. There's this gateway in between. There's always this middleman between your code and a web server, even if it's Nginx or Apache, anything. And I'm just calling it a gateway here, but typically there is something that can accept a request from your web server, Nginx in this case, do some stuff to it, and then pass it off to your code. So we'll see a few examples of gateways, and we'll talk about this, supported gateway protocols. So Nginx can talk to gateways, and the gateways talk to your application. What kind of gateways are out there? Well, before we even talk about the gateways specifically, we talk about protocols the gateways speak. Excuse me. So a lot of times we'll see gateways speak a few different languages or protocols. So things like Green Unicorn or Unicorn for Python and Ruby developers can listen on HTTP just like web servers. So they kind of act like a web server. Things like PHP FPM use fastCGI. And uWSGI, which is a Python-based gateway interface protocol, can use this uWSGI, which is just an implementation of uWSGI, to talk to your applications. So say we're using PHP, and we have a PHP application. That's this green code in the bottom of the screen you're seeing. You use PHP FPM to talk to the application. So that'd be the gateway in this picture in this case. So Nginx would send a request off to PHP FPM. PHP FPM would, to move the request, send the request to your code, and then just respond with whatever response your code makes. So PHP FPM uses fastCGI to speak. So Nginx takes a web request, turns it into a fastCGI request, sends that to PHP FPM. PHP FPM sends that to PHP, your web application, and then sends the response from PHP back to Nginx. So the gateway is doing a lot of work here. It's sort of, it's just accepting a request from Nginx, sending it to PHP, and then sending the response back to Nginx, which ends up back in your browser or however you're accessing the application. So Nginx can send requests to HTTP listeners, to fastCGI listeners, to uWSGI listeners, sCGI, which is less common but available. And it can even talk directly to memcache, which is kind of nice also. You can do some fancy caching in HTTP. So this is what it looks like to proxy a request from Nginx to another application. So in this case, a typical setup is to have Nginx. Well, let me put it this way. When we have an application, Nginx sits in front of it and has to accept requests, but we need a way to tell Nginx when to serve static files, your JavaScript, your CSS, your images, and when to send a request off to your application. So a lot of times the setup can be just to reserve a directory under which static files are served. And in this example, that's the static directory. So you can say anything inside of the static directory, any subdirectories of the static directory, any subfiles, get treated as a static file. So we see the try files again here, and it does the URI or the URI as a directory. Failing to find that, it returns a 404. And that's good for static files. The implication here being that within your application, all of your static files, JavaScript, CSS, images, etc., need to be in a static subdirectory in your web root. This isn't the only way. There's other ways to do it as well, but this is a common setup. So if it's not in the static directory, the application, or I'm sorry, Nginx will send it to our application. which listens to all other URIs other than the static one. And here it's just going to proxy pass it to a gateway listening at localhost port 9000. When you see proxy pass, that is using an HTTP proxy. So it's passing the HTTP request it gets to another process also listening on via PHP, or I'm sorry, via HTTP. So we're just shooting around web HTTP requests in this case. In this case, I have an application. It's listening on HTTP localhost 9000. I'm able to pass it a application environment of production. So this is kind of a key value pair you can send your application. That is, well, it's an arbitrary key value. So in this case, I'm using it to pass an environmental variable and telling my application to run as production. And then finally, I include proxy params, which is just including a configuration file that comes with Nginx. And that has some extra parameters that, that you usually want passed when you're proxying requests. And I won't get into that right now, but just know that you should include this, and it includes and it will send information to your gateway listening on localhost port 9000. Okay, so for PHP, if we're using PHP FPM, that uses fastCGI. So instead of listening on HTTP, it's listening using fastCGI. So again, we can see that still listening on localhost port 9000, but it won't accept an HTTP request. It will only accept one made in the fastCGI protocol. So this is a standard way to process PHP files. PHP is kind of weird in that it actually has files to match against. So, and this is not a typical case of a web application. So before we saw that web applications, or I'm sorry, before we saw that we're matching any URL that's not static and passing it to our application. With PHP, we're only matching files that end in .php and passing those to our application. So this is actually using some regular expression, matching any file that ends in .php and then passing it off to PHP FPM. Great. So really the only difference here is before we were using proxy pass. Now we're using fastCGI pass. So that's just how you tell Nginx to use fastCGI. And then we have some extra parameters here that PHP specifically needs. Because we are matching a actual file in the URI instead of a any URI that's not part of the static directory, we need to do this split path info thing on the top. Here, let me open up a text file quick. And I'll make this really big. So let's pretend I'm visiting my website at some URI index.php. Whoops. And then we have some extra parameters here. Blog post 1, something like that. So if we happen to have a PHP application run at a subdirectory of some kind, right? So some URI index.php. That entire URI is going to get passed to our fastCGI application. We don't necessarily want that. So what we use is fastCGI split path info to split the path on the PHP file. So what ends up happening is we pass this, the blog post 1, as the URL used to the application. So our PHP application will think the URL is blog post 1 and not some URI index.php blog post 1, which is a typical setup you need for things like Laravel or Symfony or your application frameworks to know and route to the proper URI so it gets to the right controller and responds to the correct thing. So that's fastCGI split path info, and then we just pass it to our localhost port 9000, fastCGI index.php. And then we have another parameter to pass our environment off as production for this application. And then lastly, we include fastCGI.conf, which just like include proxy params on the bottom here, sets up extra information that the PHP FPM process might need to successfully fill out PHP's server global array and provide server type information for PHP to use. And really, a lot of our frameworks rely on that. So you have to include this fastCGI.conf file. I'll try to show you that when we get to our questions afterwards to make that a little more clear. So lastly, I'll just show you really quick an example that's specific to uWSGI, which is used with Python. Again, we have the static directory, so any static files can get served out of that. And then we have a location directory for any other URI that's not a static file. And that will just pass this to a gateway listening using uWSGI. So it's exactly like fastCGI, exactly like an HTTP proxy. All it does is pass that off using the correct protocol. So Nginx will take a web request, HTTP request, convert it to the correct protocol for the gateway, and then send it off to the gateway. And the gateway then handles talking to the application and sending back the response. So that is a quick overview of Nginx with our applications and some configurations for that. And I can show you some more in depth as well after we get to the questions. All right, so Nginx as a load balancer. Nginx makes a pretty good load balancer. There are other software load balancers, such as hubproxy or HAProxy. Nginx does some nice things with load balancing. I kind of like it, although HAProxy is awesome for other reasons, which I can get into as well. But here is a really basic configuration for, well, it's not even basic. This is actually pretty solid. This is a good configuration for load balancing. I'll go through each of these sections, but you can see this is kind of all you would need to get started load balancing in Nginx. So the first thing you do is define your upstream, which are just servers that, I call them backend servers, but they're just the individual servers that you will be load balancing between. So in this example, I have 3 web servers. And they are just listening on port 9000, 9001, 9002. And I want Nginx to balance traffic between these 3 servers whenever it gets a request. So I've made an upstream, and I've named it arbitrarily app_example. You can name that whatever you want. Zone backend 64K, I'll explain in a minute. This one is using least connections. Least connections here is an algorithm that I've told Nginx to use to bounce between the 3 servers. So anytime it gets a new rep request, anytime Nginx gets a new request, it's gonna say, okay, I'm gonna use the least connections algorithm to decide what server to send this to. And it is gonna look at the 3 servers, and it's gonna track which have the least amount of connections currently and send the request to the one with the least amount. All right, and then you see that these have some extra parameters, right? So each of these 3 servers has a max fails of 3 and a fail timeout of 30 seconds. What this is saying is to let the server fail 3 times before it's taken out of the rotation of servers that Nginx will balance between. So if it fails 3 times within 30 seconds, Nginx will stop sending requests to that server for 30 seconds. After 30 seconds, it'll start trying again. So this gives you the opportunity to, or this stops Nginx from sending requests to servers that might be broken or down or something like that. All right, and then we get to our proxy pass section. This, I've omitted some of the usual stuff here. We'll just go right to the location block. The first thing you see here is I've told Nginx to health check the upstream servers. So health check will run checks against the servers, and if it finds a server has failed or is not responding, it will stop sending requests to it. This works in conjunction with the zone backend 64K here. Because Nginx will run with one, I mean, if Nginx ran with one process, we wouldn't need this, but sometimes, or typically, Nginx will have as many processes as there are CPU cores running. So if you have a server with 4 CPU cores, you might run Nginx with 4 processes. Earlier, I said Nginx was a single process thing, but it actually typically has just few processes instead of many, and it doesn't create new processes for requests. It just has as many as it has, and those are always running. But because we have all these, potentially more than one process running, we need some shared memory that it can use to keep track of what servers are up and running and what servers have failed. So we reserve 64K of memory for Nginx to use for health checks. So it can keep track of which of these 3 servers may have failed and which are healthy. And then once again, I include proxy params, which is just a boilerplate thing to use for anytime you're proxying to applications or to backend servers. And then we proxy pass to our app example upstream. So we named it app example. And when we proxy pass here, we define HTTP to let Nginx know to send that as an HTTP request to our backend servers. And then finally here, if you're using WebSockets, you can do that with Node.js. So you can load balance between servers that use WebSockets just by adding the HTTP version specifically and setting these 2 headers. Part of the WebSocket protocol is upgrading an HTTP request to a WebSocket request. And that is done with these headers just by saying connection upgrade and then upgrading to this variable HTTP upgrade, which Nginx sets. So if you're using WebSockets, if you need load balancing, you can do all of that. All right, so last up, I'm going to talk about Nginx as a web cache. So let's see. So we've gone over Nginx as a static website server. We've gone over Nginx as a application proxy, so we can send requests to application. And then we've gone over Nginx as a load balancer. The last thing we'll talk about is Nginx as a web cache. And when I say web cache, this implements the HTTP specification for caching, just kind of like Varnish. I don't know if any of you are familiar with Varnish, but it's another web cache, web accelerator, again in the air quotes. This will help you save web requests from actually getting to your servers. You can save the result of a request for a static file or even a dynamic request in Nginx, and Nginx can serve that request directly to a client without having to do the backend processing because it's a cached response. So Nginx can cache all the things. So static files, of course, so your CSS, your JavaScript, your images, all that stuff can get cached. And then actually it can do dynamic requests as well. So before we saw that Nginx can proxy requests to a gateway, a fastCGI, a uWSGI, an HTTP gateway, it can actually save the response from those and respond with a cached version of that. So this is pretty good for like a blog. My site, fideloper.com, the blog, uses fastCGI caching. And because it's static content, or it's not static content, it's dynamic, but it doesn't change often. So it's a good use case for having Nginx save the results of whatever PHP spits out and just sending that to a user's browser before, so that saves my server from having to actually even do any PHP processing for most of the content. And then this actually also works with load balancing. So in the same way we can save the response from a fastCGI PHP FPM response, we can also save the response from load balanced requests. All right, so some terminology to go along with cache servers. We have a cache server. So in this example, we're going to see Nginx used as a cache server. It's going to cache the results of an HTTP request. And then we have the origin server, which is a separate server. It can also be Nginx, but the point is that it's a separate server. And the origin server contains the actual files or application code that creates a response. So the origin server has two responsibilities, one of which is to have files and have an application, be able to be the authority on what the file is and that kind of thing. And it also sets cache policy, which I'm setting in air quotes again. So the origin server will say, cache the CSS file for 1 month, cache this image file for 1 hour, and don't cache HTML responses, just for example. And then the cache server has to follow those rules. All right, so this is kind of what that looks like. If we, in our browser, send a request to a website, you will receive that request first. And then it will inspect the headers of the request. And then it will also see if it has a version of the requested resource in its memory, in cache. So if my browser requests a CSS file, and then Nginx, the cache server, sees that it has that CSS file in cache, it'll just respond with the CSS file. If it doesn't, then it goes to the origin server and gets the CSS file and then sends that back to the browser. So the cache server can save the origin server from even handling any request. It's like a bandwidth and memory saver. The cache server is kind of like a frontline guard, so it can just save the origin server from ever even retrieving certain requests. So then the origin server, if it does receive a request, for instance, for that CSS file, will serve that CSS file and then tell the cache server for how long to cache it, and even if it can be cached. If it's a request for a application, for a dynamic application, then the request goes to the gateway, to your code, back to Nginx, back to your cache server, and finally back to your browser. That's just like normal. So the only new thing in this picture we have here is this extra layer, the cache server, which can handle certain responses. Okay, so here is a configuration for caching. So we have our server stuff, but above the server stuff, we have some stuff to define how Nginx can cache resources. So the first thing we do is set a cache path. I've set this for /temp/Nginx. This is just where Nginx is going to store cached files. And then I have levels 1:2. This just says how Nginx can save files in that temp Nginx location. In this case, it'll use the MD5 hash of the cache key, and it'll create some directories based on that to save files. It's kind of arbitrary. You can even not use levels, the levels directive here at all, and just let Nginx cache directly in the Nginx temp Nginx directory. It's kind of a minor point. So we have the cache path, temp Nginx, the levels, and then the next thing we have is keys_zone, and then we're just naming it my zone. So this is just naming the zone my zone, and it's a zone we'll see used below in the proxy cache. We're just naming this cache, basically. It's just called my zone, and I'm reserving 10 megabytes of cache space. So Nginx can use 10 megabytes of space for cache files. Obviously, if Nginx was being used purely as a cache server, you might want it to be pretty large, a few gigabytes, depending on your server. So the next directive we have here is inactive, and this is actually 60 minutes. So the key zone is 10 megabytes, the M is megabytes. Inactive here is 60 minutes, the M is minutes. Nginx kind of does this neat thing where if a file isn't requested in this inactive period, then it just removes it from cache. So any file that's not requested within a time period of 60 minutes is going to get removed from cache. So if you have a lot of files that are cached, this is Nginx giving you a way to say cache the most commonly requested files. So even if a file has a long cache period of like a month, if it's only requested once or twice a day, it's not necessarily going to be in Nginx's cache. So this is good for a busy site. So the next thing we have under proxy cache path is the proxy cache key. And this is us telling Nginx how to decide to cache the file. It's creating a key. So this is going to say use the scheme, HTTP versus HTTPS, use the request method, get versus post versus put, the host, so like serversforhackers.com or whatever the host name is, and the request URI. So it MD5s this information together to create a cache key. And there's other variables here. So for instance, you could add a user cookie variable here, and that would incorporate cookies into the request for the cache key. The side effect of that is that because users typically have a unique cookie, then Nginx ends up making a cache per user. That's not a typical use case of a cache server. I don't often use cookies with the proxy cache key, but if that use case works for you, if you have stuff you want to cache per individual user of your website, that's an option you have. Okay, so we're in the server block here. We just have another location block like any other. We're giving it the proxy cache named myZone, and that's the key thing to tell Nginx to cache the responses from requests made to this location block. So one neat thing here is that we add this header called xProxyCache, and this gives it the value of upstream cache status. And all that does is say, was this a proxy hit? Was this a proxy miss or bypass or something like that? So that's a neat way of just being able to look at the headers that you get back from a web request. Like you can even look at these in the Chrome Web Inspector. And you can see if the file you got back was a cache hit or miss or bypass, whatever. Once again, we include proxy params, and then we proxy pass this to a server that I happen to have listening at this IP address and port 9000. And it's going to take that and just respond and just cache the response from that proxied server. Okay, so the cache can do HTTP proxying, and the cache can actually save responses from fastCGI, and it can save responses from uWSGI. So anything it proxies to, it can save the response from, which is pretty neat because we can save the response from our dynamic applications, not just static files. And to change it, it's really easy. Like I'm literally just changing the word proxy to fastCGI or to uWSGI. Just however you proxied your applications, you can use that and cache the responses from your applications or from static files. Cool. All right, so that's all I have. I guess I'm a little over time, which is fine. I thought it would be a little short. I kind of threw a lot at all of you. I don't know how familiar all of you are with these topics. So for some of you, this might be really easy. For some of you, this content might be over your head. I don't know. But we can go over any kind of questions you have. And even if they're not related to this, that's fine. That's it.
All right, thank you very much. Does anyone have any questions for Chris?
I saw before that there were some questions from people in the email, so we can even go over some things here. Like some people wanted to talk about using Node, Nginx with Node.js, or some other stuff. I'm looking at the notes right now. Everyone's muted. I hope they're not trying to talk. Oh, let me open up my chat. Cool. So one question here is about using Nginx with Node.js. You've heard that Nginx and Node.js can speed up performance and perhaps offer some advantages to concurrent connections. How is this better or worse than Apache? So Nginx and Node.js are similar in that they are single or low number of processes. They're both asynchronous and evented. So their way of handling processes and handling requests is fundamentally different from Apache in that respect. So Apache will try to make new processes, new threads for every request and every connection. Nginx, like Node.js, will not do that. They just have a few number of processes and will take new requests as they come. But because it's asynchronous, it can just start to process a request. If something's taking a long time, it can do something else, like another request, and then come back to the other one when something is finished happening. If you're familiar with coding in Node, you kind of have this concept in your head where, it has callbacks and, something can happen and you don't know when it's finished until you get a callback from, that thing finishing. So this is good for handling a high number of concurrent requests. It doesn't actually make your application faster necessarily, but it is better for more concurrent requests because it can handle operations in a non-blocking way. Like it doesn't make you wait for a file operation or a network operation before moving on to another task. So in that respect, I think it's better than Apache. That's sort of opinion. Apache can do a lot of stuff. Apache can handle a lot of traffic. But Nginx and Node is kind of this fun combination because they both have this really similar way of handling requests and responses and processing HTTP requests. So I can guesstimate a certain PHP is still running by logging. So, all right. So I see your question from Ravi also. I'll get to that. So with Apache, I can guesstimate if a certain PHP process is still running by logging in and checking the Apache processes to see what are running, and later checking to see if that process still exists. So you can still do that. Let me see if I can do that right now, in fact. So you have two things in play. Let's see what I can see here. You have two things in play with Nginx because we have PHP FPM also. So what you want to look at instead of Apache, so Apache using mod PHP has PHP loaded in it. So every web request will include PHP also. So you can check processes of Apache running and kind of guesstimate how much memory is getting used because you have Apache running and PHP is inside of it and there's really nothing else going on. In this other setup with PHP FPM, you have Apache running and you have PHP FPM running. So you have to check your web requests against PHP FPM in addition to Nginx. And actually, if you use PHP FPM with Apache, it's the exact same situation. Because Apache can also do this proxying thing to PHP FPM. So you can see I can check my PHP FPM processes that are currently being run, and I can also check Nginx. And I have to check these separately, right? So in my server, you can see I have 2 worker processes happening here with Nginx. I have 2 cores on the CPU on my server here, and therefore I've set Nginx to run with 2 processes. PHP FPM, it works a little more like Apache where it spawns a lot of processes and threads. And so you can see just because there's people on the website and because I have a minimum number of threads hanging around, you can see that I have a bunch of PHP FPM processes also running. So you can check that out to see how much memory is getting used on average and that kind of thing. There's more stuff to check, which is a little bit of a pain, but everything's separated out in a way that lets you scale your infrastructure some more because you can run PHP FPM on different servers. You don't have to run PHP in the same server as your web server anymore. So So Ravi, you asked about my view on web security and things they need to care about while setting up a new server. There is a decent amount of stuff. Let me see. I have a Service for Hackers article on this, and it's really the stuff that I check out. Let's see, initial security and more security setup. So, so I use Ubuntu, and I don't typically use some more advanced security things like Cell Linux, which is security enhanced Linux. That is a good option for production systems. I don't use it for my personal stuff because it's complicated. But the minimum stuff I do take care of is really important, which is creating new users, making sure your root user can't log into the server with SSH, using SSH keys instead of password-based authentication. So you have to have an SSH key to log in. Making sure your users can't abuse the use of sudo. That's that's the real basics. There's user access and management. So user permissions, what users can use sudo, what users can't, what users can log in for SSH and who can't. And then of course you have network-based stuff. So setting up a firewall and basically locking down as much as you can, without sacrificing functionality. So I typically, on a web server, will just have this stuff open, SSH, so you can log into your server, and then HTTP requests can get in. But really, that's it. And then I'll open up other ports and other network interfaces as needed. So like if I had a server set up with my SQL being on a different server, or if my servers needed to communicate with each other, but not with a client, like I could open up like a private network to communicate with each other with a firewall instead of having everything blocked. So user management, logging in, the basic SSH-based security, firewalls. Those are really the basic things. Ubuntu, I also turn on automatic security updates. And this is different depending on your server type. So like this is even a little different on Debian servers. It's almost the same. But if you use if you use CentOS or Red Hat, it's a little more complicated because you can turn on updates, but not necessarily specifically security updates very easily. But that's the basics of it. Going beyond this would be to look into Cell Linux, security enhanced Linux. And that can really help you out locking down users from taking advantage of having sudo access or more access than you want them to have, or, editing certain files, using certain binaries like, delete, remove, that kind of stuff. Fail to ban. Yes, thank you. Fail to ban is also important. Fail to ban will monitor logs for certain processes like your Nginx or access logs for SSH and that kind of thing. So if it finds too many, this is all configurable, but if it finds too many failed logins from a certain host from certain IP address, it can ban them for a set period of time. And then it logs all of that so you can check out what files, or so you can check your log files to see for intrusion attempts, that kind of thing. Let's take a look at that. Fail to ban, I think, has its own folder, right? Here, I need to see fail to ban. There we go. Okay. So I'll tail the last 30 lines of file fail to ban. Come on. Oh, okay. This actually log rotated recently. But usually when I check this out, I'll have a lot of intrusion attempts. Let's check out fail to ban log 1. Yeah, here you go. So these are intrusion attempts on my server where it's banned certain IP addresses from trying to log in through SSH. Gary, I'm not currently available for hire. I'm sorry. Das, expand on how static content can be served without having just a single directory containing it all. So, Nginx, what am I looking for here? Pitfalls. Let Google autocorrect for me. This is a good site for pretty much all pitfalls. All the wrong things I've ever done in Nginx are in here. So this use of @proxy is a great way to avoid using the slash static directory. So you don't need to define a directory just for static content. So in this setup, it will try to, it'll grab for any URI, it'll try to find the file, or it'll try to find the URI as a directory, and failing that, instead of responding with a 404 error, it sends the request to @proxy. And then we name a location block called @proxy.
Sorry, Chris, we're no longer seeing your screen.
Oh, God, you're staring at me, my face. Sorry about that. All right, can you see this?
Yes.
All right, good. Sorry about that. All right, so Nginx pitfalls. Just what I described, you use this @proxy symbol here for the location block that captures everything. It uses try files to try to find a file or directory that exists. Failing that, it sends to this location block named @proxy, and then just behaves as normal to proxy the request off to your application. So that way you can have static files all over the place. And as long as you don't have an issue where you have a static file that also happens to be named a route in your application, this is a perfectly good use for not having to have a specific directory for static assets. Let's see, anything else?
Do you have any other follow-up questions?
One thing I will expand on the IP tables or failed to ban real quick. IP tables, I have to use the right command. You can see if you use fail to ban, it adds a line here on your firewall. So it will check to see if there's any banned people. Currently, I don't have someone banned right now, but this will use your firewall to ban people through IP tables. So you can see when you install fail to ban, it includes automatically a line here in your firewall setup. Someone mentioned that above. Let's see. I guess when I checked out my fail to ban log, I also wasn't sharing my screen at that point. So here you can see just some banned people from who were trying to access my server. Das, I have no idea about that for sprockets. Sorry. Cool. If you all want to see, this edition that just came out today for Servers for Hackers is actually about caching in Nginx. So you can see a little more information about how it works there. And a little bit more of an expanded idea of how that works and how I use HTML5 BP's configuration to help me determine the cache policy for certain files. Let's see. Yeah, here you see the xproxy cache miss, xproxy cache hit. That's that request, that header we added through the proxy caching section in the in the keynote. I got a question. Have I ever had issues having to restart PHP FPM after modifying Nginx configuration? I haven't. There are separate processes, so you shouldn't have to. They shouldn't be related necessarily. But if there's things where Nginx is sending certain information to PHP, it might seem that way sometimes, like the proxy settings. Changing a root directive. I don't think so, because Nginx is just pulling from there. But again, Nginx might be passing a wrong root directive to PHP FPM, and maybe PHP FPM has some processes that's still listening with the loaded PHP configuration or Nginx configuration for the because Nginx has to send information to PHP FPM. That brings up a good point. So. I'm still sharing my screen, right? Yeah. So SC Nginx. So this is not the latest version of Nginx, but you can see fastCGI params, and this includes a bunch of parameters, and these are all getting passed to PHP in every request. So the query string, the request method, one of these is probably the directory to the server root. Maybe document root here. So that might be part of your issue. So you deploy with Capistrano, and you see sometimes you need to restart FPM because you see delays and changes. I think that's because, that might be, maybe because FPM will keep a process open and accept new requests for a certain period of time until it reaches a certain number of requests before killing that process and starting a new one. So actually what I suggest you do instead of restarting is to reload it. So that's usually something like sudo service php5 fpm reload, which gracefully reloads, meaning it will drain requests of all that are currently in process before reloading. Or actually, I'm sorry, restart might do this also, but it should gracefully do it so that it won't cut a process in half, while it's in process. What else for that? I think that's about it. If you want to see, it's PHP5, FPM. PHP FPM, right? It's its own process. It's a gateway that is also speaking to your PHP application. It has these things called resource pools, and that configuration is inside with the PHP configuration. So this is how you tell PHP FPM to behave. So for instance, you can see I have it listening on, if I can find this, listening on a Unix socket, which is just a file that acts like a socket to pass information. And then you have process management. So you can tell it how many processes to create, how many to have enabled when everything's idle, so that it doesn't have to spin up new processes for new requests. The max number of requests here is how many requests a process will handle before getting killed and restarting a new process. And there's a lot of options like this. I go over all of this in my Servers for Hackers book. So when that comes out, you can read all about it. Yeah, I prefer Ubuntu over CentOS because, I mean, I know it better, really. CentOS and Red Hat both have better security with their defaults of typically having having Linux installed. So Linux kind of gets in the way of stuff until you know what's going on with it. So CentOS and Red Hat you see a lot in the enterprise, but the Ubuntu Server Edition is really solid. It's easy, and I'm in a situation where I often can get the latest software and afford to run into issues if there's software, because it's mostly like my side projects and stuff like that, and some stuff for work. But for stuff for work, we do a little more of the stable versions. But otherwise, Ubuntu. I use Ubuntu the most because I can get the latest software with all the extra repositories. So I'm always on like the Nginx stable, which is the latest stable, and not just the Nginx that happened to come out with the distribution of Ubuntu and that kind of thing.
All right, great, guys. Do we have any other questions? Or if not, then I guess that's it. Thank you so much, Chris. Thank you so much for the great time. This is awesome.
Thanks, appreciate it. I hope I didn't go over stuff too fast or anything, but I'm available online at Twitter and everything. So if anyone wants to get at me and ask questions, I'm here.
All right, thank you.